Hi, welcome to this lesson on calculus, applications of the first derivative. Let's have a look at question 3. We're given f prime this time. So now we're given the derivative of some function f is 2x plus 1. So it's a straight line. Then we want to classify any stationary points and intervals where the graph f now, not f prime, where f is increasing or decreasing. So to find these points, we need the first derivative, but we've been given the first derivative already, which is great. Okay, so then we can start classifying immediately. For stationary points, it is simply when your first derivative, f prime, is set equals to 0. So this implies that 2x plus 1 must be equal to 0. Then solving for x, we have 2x equals negative 1, which implies x must be negative a half. Okay, so at x equals negative a half, you will have a stationary point. Now, because we don't know the original function, we can't necessarily find the y value. So this is as far as we can go right now. But if you ever go further and you look at integral calculus, we can actually see from a given derivative what a function could be of that given derivative. Okay, and because it's a linear, we saw from the power rule, usually it goes one down. So if we work backwards, the degree would go one up. So we most likely have a quadratic function in the original question. Okay, but for our purposes, the stationary point's just at x equals negative a half, and that's where we'll have a stationary point. Okay, next, what are we looking for? When is the graph increasing? So again, when your first derivative is set greater than 0, that is when your function f is increasing. So that's 2x plus 1 is greater than 0. So it's a linear inequality and we can solve it. So 2x is greater than negative 1. And then x is greater than negative a half. So that's performing the same algebraic techniques. Okay, so that's the inequality notation, or the way I would like to write it is x is an element from negative a half all the way to positive infinity. Okay, and then lastly, when is it decreasing? So f prime x less than 0. Well, that is when 2x plus 1 is less than 0. So again, if we follow the same algebraic techniques, we get x is less than negative a half. Okay, or in interval notation, that is when x is an element from negative infinity all the way up to negative a half. Okay, and we can sort of get a rough idea of what this ends up looking like, because here's our Cartesian plane. We know that at x equals negative a half, there's some sort of turning point for the function somewhere on this line. Okay, so it could turn on any of these points on this vertical line, x equals negative a half. And then we know that less than negative a half, the graph is decreasing, so it's coming down somewhere. And then it must reach a turning point, a stationary point in this case, where the tangent gradient will be 0, and then begins to increase again. So you can see from this given information, we can kind of get a rough idea that this most likely is a quadratic function. Okay, so for example, maybe if we did y equals x squared plus x plus 1, just as an example, it's not necessarily saying this is the function. But then if you take y prime, the derivative, we get 2x plus 1. And that's exactly what we have here. So you can start to build a foundational knowledge of how to work backwards in differential calculus, which is actually integral calculus. All right, and it's very good to think about those things. All right, so that is how we would do this type of question. I'll see you in the next one.